Okay, let's get started. I'm David Cole, Senior Engineer Manager at SUSE. So today let's talk about Longhorn, how Longhorn become a comprehensive and agile solution for cloud native storage. This agenda, we will talk about what's a Longhorn, how it works, and three primary parts to make Longhorn as an outstanding solution in the market. Kubernetes native, agility, run anywhere, comprehensive capability. And then take a look what's new in 1.5.0, the latest release of Longhorn, have a short demo, and to see what's the plan after 1.5.0 is primarily for 1.6 and 1.7. Okay, what's a Longhorn? Longhorn is a highly available software-defined persistent bar storage for Kubernetes. Built on Kubernetes, built for Kubernetes workload. It's very lightweight, reliable, and easy to use. We even provide a very straightforward UI to let users to operate Longhorn. And it adds the persistent volume support to any certified Kubernetes cluster, including public cloud or even edge environments. Storage agnostic, it supports EST4 and XFS file system can be added into as a Longhorn disk, and not just in cluster volume capabilities supported by Longhorn. Longhorn also support out of cluster functionality like backup and restore. And right now we support two type of backup store, including NFS S3, and we will have a new uh, protocol support later. I will present. It will be introduced in 1.5.0. And Longhorn is based on Kubernetes. So it's Kubernetes first design, adapt this kind of design. They leverage the CRD customer resource and also control pattern. And for sure, it's an open source project owned by CNCF. Right now, he's incubating. The goal for Longhorn is go to graduation. And what's the long inside? The architecture. There are actually four parts here. The first one, control plane, is built by Kubernetes controller and customer resource. So we have a different type of resource for different long capability. For example, long have a long volume, long engine, replica, or even backup, back image, etc. So we have a corresponding controller to respond for the reconciling the status change or config change of each customer resource. This is about control plane. The data plane, how the volume can be represented for the user, for the workload. So there are three parts here. The first one, volume front end. Right now, long current volume is based on iSCSI. So for user, they can use the volume is exposed by iSCSI target server launched by Longhorn. And for each volume, we also have an engine process and can control all the data flow and management the downstream replicas. So the replica will be real data will place in the replica in in each node. In each node, it depends on how many replica you will have for your volume. So three parts here: front end, volume engine, and volume replicas. Okay. Next, volume lifecycle. Longhorn based on the standard interface, container storage interface to fulfill the volume lifecycle, and also based on Kubernetes building resource, PVC and PV, to make sure we can understand when to create the volume for the workload and when we need to delete the volume or reclaim the volume. And data placement, the replica data will be placed into a long disk. As I said before, long disk is file system agnostic, so we support XFS and EST4. And if you look into the right hand side, the diagram, we can see the end-to-end flow is like this. You have a workload pod, you request a Kubernetes volume, and Long will be aware of that and create a corresponding volume composed of an engine and downstream replicas. So engine will help the coordinate with the replicas, and later you will export the iSCSI device next to the engine to let the workload able to use the volume. And replica, if you see, it will be set in the different node by default. We have like an NT affinity policy for the node level. So, but user can design the settings. So for example, by default is true. So replica definitely will be placed in the different nodes, and each node have probably more than one long disk. So you will be placed in the different disk. And if the node downs, one of replica downs, for example, an engine have a downstream legacy replica by default. If your one replica down, your engine still be able to reach out to other replica to make sure the I/O continue and serving the traffic. So your part will be not be disrupted, will be continue working as normal. So this is how Longhorn work right now. And Kubernetes native, as I say, Longhorn is built on Kubernetes, run for Kubernetes. So based on two parts, I want to emphasize again, customer resource. The main purpose is after the Longhorn resource put into each customer resource. So he's an official interface to let user to operate Longhorn. For Longhorn, we have a Longhorn UI, so user can operate. We also have an informal RESTful API, so user can operate. But official interface for users, it can sue the customer resource to manage Longhorn directly. And each customer resource have a corresponding controller will be handled and reconciling the customer resource status and configuration change. And also, we will manage and monitor Longhorn component dynamically to make sure Longhorn can be react to different requests and react to different situation or even resilience handling. Okay, so simply said, when using Longhorn, you don't need to you need to have an extra database for persistent Longhorn status because all the things saved in Kubernetes by customer resource. Longhorn only rely on customer resource to persist in everything, including the season status, season configuration. So this is what I call it Kubernetes native to make sure Longhorn can run on any certified Kubernetes. Agility running well. The goal for Longhorn is not just the persistent volume solution for Kubernetes. We also want Longhorn can run on anywhere, anywhere, like on premium, cloud, or edge. So here is what we have done, and probably have something we plan to do later. Depends on the customer or user feedback. The first one, distro. Any certified Kubernetes Longhorn can run on it, including vanilla Kubernetes or RKE, RKE2, K3s, etc. For architecture, Longhorn not just run on AMD64, we also can run on ARM64 and S3 90X architecture. And for install and upgrade, we have a unified way to let the user install and upgrade Longhorn by Hamcha, or you can leverage Ranger. Ranger have an application marketplace. You can install and manage Longhorn layer. And also, because we want to run Longhorn run anywhere, so we need to make the upgrade process and experience smooth. So upgrade Kubernetes upgrade awareness is Longhorn can support by leverage pod disruption budget and drain operation. So Longhorn will be ensure the running volume replica available before drain the nodes by using PDB to protect the Longhorn components. This is what we have done recently. So this is best practice for user when their cluster install there's a Longhorn install layer, they still can do a Kubernetes upgrade without any data impact or data lost. And how about infrastructure? Infrastructure, the goal is run on-prem, cloud, edge, anywhere. So on-prem is one outstanding example is Harvester. Harvester is an open source project by SUSE, and he's leveraged several open source projects to make the hyper-converged solution for virtualization purpose. So the underlying storage is Longhorn. It already adopted many users and or even enterprise level use the Harvester. So it's really verified by the market. So for cloud, public cloud we also support it. and we have a dedicated pipeline to test the AKs, EKs, GK, including the upgrades. And we also support cluster auto scale because we know that scalability is pretty important when your environment or your Kubernetes cluster running on cloud. So this one we support. And for cloud distro, they have a different strategy for the no maintenance or no upgrade. This also be support, and we have a corresponding strategy for that as well. When you have a Longhorn install in your cluster on cloud, and you can do a no pull upgrade without any data lost. Age, especially the environment has a resource constraint. We already verify and claim we can support Sleep Micro. Sleep Micro is most of the time used in the age side, and also we verified that some scenario can make the Longhorn work okay, well for with a low resource footprint environment. This is how the way the strategy you want to make the Longhorn to run anywhere. Comprehensive capability, not just the volume functionality. Longhorn want to do more, including the data management, data service in or out of cluster. So here are the several items I want to emphasize how Longhorn have done right now or even plan for the following release and want to have some difference if you do some comparison with the solution in the market. The first one, Kubernetes Persistent Volume Support. Right now, Longhorn support the block and file system volume. But in later version, we will support object storage interface as well. Because we know the modern application really rely on object storage for some data processing or extra or like data archive stuff, this kind of different purpose, especially adopted by application, modern application. So we want to do that. So in next 1.6, we will have a experimental feature for object storage interface. For SS mode, rewrite only and rewrite many, we also support that. So this is very important. We cover the different volume mode and SS mode. CSI protocol support. Longhorn want to make the Longhorn capability functionality based on standard interface, so this is mandatory, including the volume provision, attachment, snapshot for different type of snapshot, clone, and expansion. Volume capability, simple provision, snapshot, clean, live upgrade without any downtime when you do the volume upgrade during the Longhorn upgrade. I/O performance, we have a data locality or even introduce a local volume first version in 1.4. And in 1.5, we will have the data engine, SPK data engine. So you will be have a outstanding performance improve compared with the current engine. Storage topology. Long is a node and zone awareness. It can be make sure your replicas available in a different node or even cross node. So we have a different type of settings user to allow the user to setting. For example, like a node anti-affinity or zone anti-affinity. Storage tag, you can tag your disk and have the latter have a different strategy to decide where you want to place your data. Data protection, we rely on data replication. This is a long volume basic functionality to make sure data available even you lost one or even two replica if the replica number is three. Data encryption to protect your data in transit and at rest. Bureau protection to prevent any corrupted replicas, including corrupt snapshot, and even better to correct them to review the replicas to make sure your data intact and with the data integrity. Data service, we want to have not just in cluster and also out of cluster, like in cluster backup, snapshot, or out of cluster backup and restore. And based on that, provide the long haul strategy and story for disaster recovery. Data reduction. Space efficiency is very important if your system is based on snapshot. And Longhorn have a different recurring job type to let you can decide what kind of strategy for your space efficiency, what time you want to clean out your snapshot based on your space plan. And also in one file, we introduce a backup compression. So that means can make your backup compression and backup restore more faster, much faster, and also save your space usage. So this is a comprehensive capability I want to emphasize. Not just this, we will do more for Longhorn based on the user feedback and the real scenario they are right now using the current and modern workload implementation. So simply said, to conclude, why we need that? Because resilience, availability, consistency, reliability, and fault tolerance are the peers for all the capability. So when we introduce this kind of capability, this peer we need to make sure we can fulfill each one to make sure the long quality as well. Okay, so let's talk about what's new in 150. We try to we have a consistent release cadency for Longhorn. So two feature release 1 year and 3 months for each patch for the maintain and support release branch. So 1.5 is the latest release. And what's new inside? Class Auto Scale become GA. Class Auto Scale we introduce it in the 1.4 and as a experimental features, especially for the public cloud distro. And we hear more feedback and make sure we have a dedicated testing pipeline for that and to make that us can make it GA in this version. So right now I'm happy to say he's GA right now and want to hear more feedback later. And instance manager resource. We have an instance manager and engine and replica to two parts currently. And when you're doing the long upgrade, you will increase it four parts because we want to make sure volume no disruption upgrade. But however, there will be cost extra pre-allocate resource, a special CPU for these parts. So in 1.5.0, we designed to consolidate engine and replica parts to one, so to lower down the pre-allocate resource for these parts. So you will be lower the barrier for resource requirement when you use a long or even during upgrade. Automatic file system trim and rewrite manning for space efficiency. File system trim already introduced in 1.4. However, user need to do it manually. So in 1.5, we have a specific recurring job type. So you can create a recurring job to make a file system trim regularly to save your space. And also we introduce a trim rewrite manning, not just rewrite only volume. So this is good for user because rewrite manning volume actually use a lot of place when you want to share volume with a different workloads. Upgrade path enforcement and downgrade prevention. We want to make the upgrade path smooth without any surprising problem, especially you do some cross version upgrade, something like that. So upgrade path enforcement will make sure you upgrade from the right version, right source version to a right destination version. And if upgrade path is wrong, you will not be allowed to upgrade. However, we will allow you roll back to the correct state without any data loss and data intact. And downgrade as well, we will not allow user to do any downgrade to prevent any unsurprising things about the backward compatible for the data engine, something like that. So the same, if you downgrade fail, we can allow you to back to a normal state without any data loss and data keep intact. Long volume attachment for exclusive attachment. This is the way we want to resolve the multi-attachment problem before. Sometimes it will be happen. So after 1.5.0, this problem is actually resolved totally. SPDK a data engine for I/O performance. For Longhorn, everyone appreciate all the functions. Very happy for the function provided by Longhorn. But one of challenge is performance, I/O performance, because right now we based on iSCSI stack. There's a context switch efforts and resource effort for that. So there's a bottleneck lag. We cannot resolve that easy, especially kernel pace. So we introduced a second next generation data engine based on SPDK to unlock I/O performance bottleneck, and it will be in 1.5.0. And I have some numbers to share with you how the performance gain we bring into 1.5.0 by this new data engine. Back image management. A user can use a UI or backing image customer research to manage back image. But this is more about the Longhorn way. We want to make the back image management by CSI volume essential together with the in-class essential out-of-class backup to make us a standard interface for users. Kubernetes upgrade awareness with the no drain policy. As I say, we leverage PDB, PROD disruption budget, to protect the Longhorn component not be drained if we cannot match your volume replica available. Next, essential delete and clean up. In 1.5.0, we introduce a different recurring job for specific efficiency. Like I said before, automatic file system trim, and here we have a essential delete and clean up. For some case, the volume, when users don't really care about the snapshot, they can do addition or clean up for that. And lastly, backup store support. As I said at the beginning, Longhorn support NFS and S3 compatible backup store. And right now, we can support Azure, blob storage, and CIFS to fulfill the different scenario and different backup strategies by users. So this is what new stuff in 1.5.0. Okay, I will have a short demo to showcase a long SPK data engine. And I have prepared a 3 nodes cluster, and long has been installed here. And, but SPK is not enabled yet. We need to enable it first. So the requirement for that is we need to make sure the huge page support by each node. Okay. So if you go back to see the node information, you will see the huge page. Huge page is 0. So we need to update this. And how to make the your Longhorn can be run for based on SPDK. You need to install some dependency. Uh, we provide some dependency manifest for that. So you can see here, if you look into the Longhorn repo deployment folder, we have a requirement for that. And you will see 2 new stuff. One is NVMe CLI you need to install because how we operate the front end part, we use the NVMe CLI to manage the NVMe volume export by SPDK. And second one is the SPDK setup. And if you look into SPDK setup, it's actually do the huge page update. Okay, so this is what we need to do. And if we back to the node, we will see. Okay, we already run that. So let me see. Okay, so it's no log here, but let me already update, already enable the huge page. But what we need to do first, we need to restart the kubelet to make the huge page take effect. So let me restart it. I have the command to do that. So you can restart the kubelet for each node, and we will see how it take effect. Then after it take effect, we can start to add the SPK disk inside, because each node I prepared an extra block device for the SPDA purpose. Okay, so let's see. Go into check the nodes, see a huge page change or not. Yes, it's changed here. 2 megabytes to 1 gigabyte. Okay, each node should be the same. Okay, let's back to Longhorn UI. This is UI page. Okay, so there is pull forward already gone. So I need to restart again. Okay, it's back. So right now what we need to do, we need to add the extra disk for SPDK. Okay, so we need a new disk and enable it. Before you enable it, and also add the device BDB, if I remember correctly. BDB. Okay, and change your disk type. It's a block. Okay, and set. Oh, yeah, this is right. We need to change the setting first. Because we don't enable SPK by default. We need an extra resource. So you need to change it. Make a check and enable. And later go back to the same page and add the disk again. Change to block and enable. Save. And we will do a same for others, because I add the same new PROD device for all the nodes. Enable PDB PROD device. Yes. And also next one, add a new one, new disk. This one, following. Type. This type right now we introduced two type, is a file system block type. And for SPK volume, it will be block type. And remember to enable it. Okay, so this is scalable, and let's wait for this one. Yeah, I think it will be scalable soon. BDB, and yeah, we can check it later. Yep, available. And let's create volume. Volume one, and there's a small size. For example, 1 megabyte and 3 number replicas. And you can change your data engine. We have old one and new one. We change the new one. It will be detached by default, right, as usual. So you need to attach a node, and the replica will start to create. Okay, it's creating now very fast. Okay, so if right now, and the current scenes for the 1.5 preview, SPK volume does not support online rebuilding. So that means when you delete the replicas, or replica have something wrong, you cannot rebuild immediately. However, we support this one. It's called offline replica rebuilding. It will be introduced to SPK volume first, but later it will be introduced to all type of volume, including current ones. So we need to enable this one. It already enabled by default. So if we check, this still degrade, right? So if we detach, then you will be automatically rebuild offline. If we check into, is everything is doing automatically for the rebuilding. and he will reuse the original replica from the DD one to make it continue to serve. And after it back to normal, it will detach again to keep state in the original state is detach mode. So when you try to attach again, you will see it work well. Okay. So this SPK, please give a try to see how it works. And of course, 1.5 does not have many features as the current engines. We have planned for the feature parity implementation in 1.6 is by end of this year. So at that time, it should have a very similar capability as the current engine. Okay. So let's have a glimpse at 1.6 and 1.7. 1.6 is end of this year. 1.7 is next June. SPK, yeah, SPK in 1.5 just preview. We can make sure we support the one life cycle of live rebuilding, etc. But for the experimental 1.6, we have a complete functionality based on the feature parity features of the current data engine. And for 1.7, it will become GA, so can be used in production environments. If you look into these three metrics, performance benchmark result, IOPS, bandwidth, or latency, you will see the new and valid and new engines will be performed very well, similar to very close to the raw disk, which run by local path provision. If replica number is one, but if whatever numbers of replicas, it perform very well, better than the current stack. Current stack is grade one, even two times or even more. For bandwidth, the same is improved, but it's not improved like two times because it really depends on your underlying disk performance. But it will improve well as per your underlying performance. And latency improve a lot, two times improve if you compare with the previous stack, the current stack. So this is the Longhorn new SPK data engine to unlock or unleash our performance charge in the previous version. And in 1.6, we will introduce the object storage interface, object storage volume. The underlying engine is S3 gateway. We will make it happen together as our third interface, storage interface. We have a block interface, we have 5.6 interface. In 1.6, we will have object storage interface. And in 1.6, we will support S3 API, bucket management, and UI enhancements, and deployment, dynamic deployment based on the volume. If the volume is object storage volume, you have a bucket engine provision as well, and of course corresponding customer resource for that. And for 1.6, we target 1.6 to become GA, so no downtime upgrade, HA deployment to make sure he can actually the object storage volume can be work well in the production environment. So this is the two primary items. Not just that, but the two primary items I want to share a little bit about the 1.6 and 1.7. But please follow the Longhorn release plan roadmap. We have that on our GitHub reports, Longhorn GitHub reports, and also give more feedback if you see any opportunity based on current modern usage in Kubernetes. We can see how we can add or improve, enhance along the time in the following feature release. Yep, I think that's it. Thanks everyone. Hope you enjoy this talk. Thank you.